Okay, question 1.1. It says consider the arithmetic sequence 8, 15, 22. And 1.1.1 says determine the 36th term. Now, in order for us to get the 36th term, we have to get the general term first. Seeing that this is an arithmetic sequence, we know that it is in the format Tn is equal to a plus d into n minus 1. Once we have that, we can then substitute 36 in place of n, and that would give us term 36. Okay, let's do that. Now, looking at what we have, our first term was 8, 15, 22, so the difference is 7. We are adding 7 each time. So we're going to have 7 into n minus 1. We're going to take that 7 and distribute it into the bracket, gather like terms, and our general term is 1 plus 7n. From here, we want to get term 36, so we are going to replace n with 36. And that gives you 253 as the 36th term. So that was quite simple. Now 1.1.2 says calculate the sum of the first 36 terms. So in order for us to get the sum, and considering that this is arithmetic, we know that we have two formulas. However, in this case, we can actually use the shorter formula, n over 2 into a plus l. And the reason why I'm using this formula is because we are calculating the sum up to the 36th term. So that is the last term. And since the last term is known, we had just calculated this. We can use a formula with a plus l. So we are getting S36, which should be 36 over 2. First term is 8. Last term is 253. And you just got to plug this into your calculator. You should get 4698 as S36. Now 1.1.3 says if it is given that T72 plus T72 minus M is equal to 786, determine the value of M. Now the thing is, we don't know what term 72 is. Neither do we know what term 72 minus M is. But we can calculate those and then work with this equation. And obviously because we have M, which is a variable, this equation should allow us to solve for M. Okay, so I just want to write down what we're given, so we're just taking note of that. Term 72 plus term 72 minus M is equal to 786. So here's my approach. I'm going to calculate that first part, then the second part, and then I'll come back to this equation. Okay? So let's get term 72. We're just going to substitute into the general term that we had. So it's going to be 1 plus 7 times 72, and that is going to give you 505. I'm now going to calculate term 72 minus M, meaning that in my general term, I'm going to replace N with 72 minus M. So I'm going to distribute the 7 into the bracket with both terms. That's going to give me 504 minus 7M. I'm now going to gather like terms. I have 505 minus 7M. And now that I know where those two terms are, I'm now going to come back to this equation. So on the left hand side, I've got 505. There is a plus. I'm replacing term 72 minus M with what it is. It's 505 minus 7M, and all of that is equal to 786. On the left hand side, we are going to gather like terms, which is going to give us 1010. minus 7m is equal to 786. Since we are trying to solve for m, I'll take the 7m over to the right hand side to make it positive. I will take the 786 over to the left. It is going to subtract. That will give me 224. And lastly, I'm going to divide throughout by 7. So I get m is equal to 32. That is actually what they wanted you to calculate. You were asked to solve for m here. So that means that we are done. So we are now looking at 1.2, and we notice that we've got a pattern that is a geometric series. And in this pattern, we have variables. So our first term is x minus 2 all squared. Second term, x minus 2 all cubed. Third term, x minus 2 all to the power of 4, and it continues in that manner. So the bracket stays the same. The base is x minus 2 throughout, but the exponents are increasing by 1 each time. So 1.2.1 says write down the common ratio. So we need to know what r is here. Just by looking at it, we can see that r is x minus 2. So you can actually just write that as your answer. But if you want to see how this would be calculated, I'm going to take term 2 over term 1. That would be x minus 2 all cubed over x minus 2 all squared. And using laws of exponents, we can see that 3 minus 2 is going to give us 1. So r would just be x minus 2 all raised to the power 1. But because it's an exponent of 1, we can just leave it out. So that is r. Now 1.2.2 says determine the values of x for which the series will converge. I've mentioned this in a previous video where I said that in order for a series to converge, r must lie between -1 and +1. And I would actually suggest that you write that down. So I'm going to say for a series to converge, and my condition is that r must lie between -1 and +1. In the next step, I'm going to replace r with what it is equal to. So r was equal to x minus 2. And my aim here is to solve for x. So you guys are quite familiar with how inequalities work. You've worked with this in grade 10. You've even worked with this in grade 11 as well. So to get x alone in the center, we are going to add 2 onto both sides. The reason why I'm adding 2 is because I've got a -2 that I want to cancel out. On the left hand side, if I have -1 plus 2, that gives me +1. On the right hand side, 1 plus 2 gives me 3. That tells us that for this series to converge, x must lie between 1 and 3. And you guys, what does it mean if the series converges? It means that we get a sum to infinity. It means that after a certain point of adding terms, the sum does not change. So we are done with this question.